For our next talk, let me introduce you, Joel. Welcome, Joel.
Hey, thanks, Monica. Thanks for having me.
Thank you. Thank you for joining us. Well, today we have Joel Hawksley, directly from GitHub, the creator of ViewComponents. And guess what we're going to be talking about? ViewComponents. But the interesting part about this is not only about, ViewComponents per se, but what I love is that you are going to go around how do you build a community around something that is a new part of Rails, something that is already so big? How do you nurture something like that? How do you open source a library of ViewComponents and actually scaling an application to hundreds of them? It's going to be not only about theory, but also practice, I guess, and how to bring ViewComponents to live for the whole community. I'll leave the stage to you. Thank you so much again for being with us.
Wonderful. Thanks for having me, Monica. I really wish I was with y'all in person in Italy, but this virtual experience will have to suffice. But here
we miss you too.
Yeah, maybe next year we can all be drinking some wine together somewhere in some beautiful place in Italy. Anyways, all right. Well, my name's Joel. Thanks for coming to this session. Today, I'm going to share some lessons we've learned building ViewComponents at GitHub over the past year. So I'm an engineer on the design infrastructure team at GitHub. We're responsible for the primer design system that's used throughout GitHub. As you can see, it's really a system of systems. We have a CSS framework, we have React components, we have a library of ViewComponents that we'll be talking about today, and a bunch of other pieces that you might expect in a modern design system these days. So my job on the GitHub design infrastructure team is to make building consistent, accessible, resilient user interfaces in our Rails monolith an enjoyable experience. And doing this all at what I would call a pretty incredible scale. Whenever I give talks about our monolith, people just always ask me about, how big is our application? So here's a few stats. The GitHub Rails app is over 13 years old, and it receives tens of thousands of requests per second. We've extracted around 24 services from the application into what a lot of people would call a Citadel architecture. A lot of our services are actually written in Go, and they include some functional areas that you might be familiar with, such as webhook delivery. But most of GitHub that you interact with is still a Rails monolith, and it's a monolith that continues to grow very quickly. So to give you an idea, we have almost 600 models in our application. That area has grown about 33% over the past year. We have almost 4,700 views, and that area has grown almost 20% over the past year. And we have over 800 controllers, a growth of almost 37% over the past year. And I think perhaps most importantly for our design team, we have over 2,000 pages in the application. And all of those pages need to stay current and up to date in terms of our design standards, even if there are some obscure settings page that's out of the critical path that you might not even know exists. So this scale makes for some interesting problems. You can imagine that things that might be a small annoyance in smaller Rails applications can quickly become serious roadblocks at our scale. So I'm going to start by sharing some of those serious roadblocks. When you have a body of work this big, you really start to see some of these patterns emerge. And, one of them that we've really had is just figuring out what template renders what part of a page. So, for example, if we're looking at a pull request page here, if I want to edit this draft badge that displays the status of a pull request, how do I find the right place to make my change? So one way you might do this is you could try searching for specific class names that are on the element here. You can see we have some functional CSS class names. But because these aren't unique, it's not a very reliable approach. So in this case, if you were to search for these class names, you might get dozens of results. In this case, I think you actually get hundreds if you look for some combination of these. So in thinking about this problem, we came up with the idea to add HTML comments at the beginning and the end of every template's output with the path of the template file. And we did this by writing a custom ERB compiler. So this ERB compiler starts by defining a subclass of ActionView template handlers ERB. And we define a call method that really receives a template object. This is how all of the Rails template handlers happen to work. The first thing we do is we take the output of the superclass and assign it to a variable. And then we grab that template object and render HTML comments using the path attribute before and after the output of the template. We then take that compiler and register it as the handler for ERB files in Rails. So if we go back to our page, we can now see which template rendered which part of a page. In this case, it's actually a view component that we've written for to display the state of a pull request. So after seeing the benefits of this patch internally, we actually extracted this into Rails. This is part of Rails 6.1, and you can turn it on with the configuration variable config ActionView annotate template file names. And if you build a new Rails application today, this is actually turned on by default in local development. So another issue that's come up at our scale is that it's really difficult to get our application into the right state, especially when you're in local development and you want to test visual changes. You can imagine if you're a designer and you have a feature, a unit test isn't sufficient for verifying your visual changes. And a lot of these difficulties come due to the fact that we have this Citadel architecture with a lot of services. As I mentioned, we have a Rails monolith with about 24 external services, and this can make that kind of local reproduction problem really difficult for us. And you might think, why don't you just use some system tests, for example? And we've considered this, but they would add a lot of time to our test suite. But we do write plenty of controller tests. And after pairing with our designers a bunch and really struggling to help them get just the user in just the right place with the repository, with these certain files and everything to reproduce a feature, I had an idea. What if we could convert our controller tests into system tests? That way we could reuse all of the existing setup code, the stubs, the mocks, the fake external services to preview our application in a specific state in a system test. So as a quick refresher, this is what a controller test looks like. It calls get with a URL, and then it makes an assertion, in this case, asserting against the response code. So how can we convert this into a system test? So we can start by writing a module. We'll call it system test conversion. And when this module is included, we'll register some basic configuration for action dispatch system test case. Then in this case, we just need to redefine that get method to visit the path that we provided and then pause with a debugger. And then we, for the assert response, we don't need it in this case, so we just write that as a no-op. So from there, we look for a runtime environment variable. This would literally be just like prefixing your test command with run in browser. And if that is the case, we go ahead and include that module into our base controller test case. And here's what it looks like. So you can see that we're running our controller test. We actually also add a login step in our case to log the user in. But you can now see that we're previewing our application with a converted with a controller test that's now been converted into a system test at runtime. So unlike template annotations, this feature hasn't made it into Rails. It's dependent on our specific architecture, but it's really served us pretty well. But I also think there's kind of a more general lesson here, and it's that our seeds in our test setup code have a lot of overlap. And I'm curious if there's a better way we could bridge the gap between these conceptual domains, especially when we're working with external services like we are at GitHub. So while working on these projects, we identified another source of friction. You can think, we just talked about identifying which template is used to render which part of a page. You can also imagine that when rendering a template, at our scale, it could be really difficult to know where it's used. If you don't know where a template is used, changing it is risky, especially in a case like ours where we reuse our partials a lot. To help understand this problem, my colleague John Hawthorne actually made a diagram of how our templates reference each other. And I don't know how well this will come in over the stream, but it's a massive ball of spaghetti. And as you can imagine, navigating this render stack is probably pretty tricky, which means that it might not be super confidence inspiring to go and make a change to one of these templates. So to try to get a handle on this problem, we built a tool called Viewfinder. And this is how it works. So you pass in the path to a template. In the case of this example, we're going to use the wiki show page. So say I made a change to the wiki show page, I pass it into this command line tool. And we start by extracting the template string literal. In this case, it's wiki/show, and we'll search for it in the code base. So this is literally just like a Ruby implementation of Command-Shift-F in VS Code, just a global text search. And then what we'll do is for each of our search results, we'll load the resulting file with the parser gem, which returns what's called an abstract syntax tree of the file. So for example, here's one of the matches for our search that happens to be a controller, and here's part of its syntax tree. This data structure represents how Ruby interprets the code that we write every day. As an aside, this is actually how Rubocop works. It translates Ruby into these data structures and then performs operations on this intermediate structure. So as you can see at the bottom of here, we have our render call to wiki/show. And we're doing this parsing step so that we ensure that any of those like Command-Shift-F global search results actually are render calls that are to this specific path. So just to take a step back, this is the equivalent controller code for the syntax tree we just looked at. So you can see this is kind of like your typical respond to format HTML. You've probably seen this in Rails applications you've worked in, and then the associated syntax tree. So what's really cool, as I kind of mentioned with Rubocop, is that once you have the syntax tree, you can actually run queries against it. So I'm not going to go into too much detail at this point, but we're able to find all the calls to render by looking at the type of the node in the syntax tree and then at the method name. So we can do this to see that, like, okay, this method name is we are actually calling the method render. And like I said, we do that to confirm that that this render call is actually for that template we're trying to trace. And we continue this process over and over again recursively until we reach a controller action. Once we're in the controller action, we actually query back up the tree. And we do that until we find the definition of a method. In this case, we found the definition of a show method, which means that in this case, we are in wiki controller show. So from there, we look up the routes that render that controller action, and we return the result to the console. So here's what we've ended up with. We've entered bin viewfinder and then the path to our wiki/show template, and it's shown us that we have two routes that actually will route to that template. So you can see that the star matcher here goes to wiki controller show, and then /repository/wiki goes to the index page. Both of those actually happen to reuse this template, which means that we can now know where to go when we want to verify that we haven't broken something in our application. So, by itself, this tool has been really useful for us. We could use it to see all these routes that rendered a specific template. But then we realized we could use these routes to identify which controller tests rendered our template. And we did this through a combination of processes of what got us to this point. We started by finding all of the get calls from our controller tests, as we looked at a minute ago. So for example, here's one that loads the wiki for this example repository. We extract that part of the path, and then we actually just reuse the piece of Rails, in this case, Rails application routes recognized path, that takes a path and turns it into that routes it to a specific controller action. So we pass our path in there, and we get this hash back that includes the name of the controller, the action it's determined, and then in this case, it's extracted those URL params as well. We'll ignore those in this case. And we repeat this process over and over again, actually for every single controller test in our test suite. And we build up a hash that we then cache heavily in a file that looks something like this. Basically, we have the controller action as the key and the matching tests as an array of values. What that lookup then gives us is it gives us the ability to then include which tests render a certain view in our system test conversion tool. So we then use these cases to verify changes to our template in a browser. So what this literally allows us to do is to go from, I have a name of a template, to here's a test that will automatically reproduce the page that renders that without me having to do any local setup in my environment. Now, unfortunately, this only works with explicit render calls where the template name is passed to the render method. This is something we enforce with a linter locally for other optimizations we do in the GitHub application. But that means that this isn't going to work in just any Rails app. This also really doesn't account for conditionals. It's kind of an optimistic approach. It'll give you all the possible routes you could use. But despite all those caveats, it's proved really useful for us, especially for our designers as they go in and make changes and need to quickly reproduce them. But perhaps the biggest challenge that we face as a design infrastructure team has really been what I would refer to as a missing abstraction in our view layer. So a common rule of abstraction is the rule of three. One of my favorite Ruby books of all time is Martin Fowler's Refactoring. And the section on the rule of three says, the first time you do something, you just do it. The second time you do something similar, you wince at the duplication, but you do the duplicate thing anyway. The third time you do something similar, you refactor. And I think we're all kind of familiar with this process. Usually when we do something over and over again in our Ruby code, we abstract it. If we don't, our code becomes inconsistent and hard to maintain, and you can imagine the other problems that come with duplication. And this is especially true in our Vue code. We often build templates by copying existing ones. And through this process, it makes it incredibly difficult to make sweeping changes to our code, especially in our views. And this, as you can imagine, we're a design systems team. Our leverage is being able to make sweeping changes to design all across GitHub really effectively. And this duplication really limits the impact we can have. So in 2019, I had a crazy idea for using Ruby objects to render views, inspired by some ideas from React. We now call it ViewComponent, and it's a framework for building reusable, testable, and encapsulated Vue components as a natural extension to Rails. And a Vue component is pretty simple, at least in its basic form. I'll kind of go over this one here. A Vue component is a Ruby file, and it often has a template as well. So the Ruby file you can see on the left, our test component RB, it just has an initializer. It assigns an instance variable of title. And then in our template, we have a span that uses that title as the title attribute. And then we have this special content accessor that will have the content we pass to the component. So to render it, we instantiate the component and pass it to render. This is the ability to pass objects to render is the key change to Rails that we made to support this framework. You can see we're also passing a block here that says hello world. When we render this, we get the following HTML. We've passed in that title attribute, and that block has been captured, assigned to the content accessor, and returned inside our span. So to test the component, we can write a unit test, and that unit test will render the component and then assert against the output using matchers from Capybara. And these tests are really, really fast. In our code base, they're around 100 times faster than our controller tests. So we're talking like a 25 milliseconds versus like 6 seconds for a controller test. And having this ability has really been a game changer for us. I don't know about y'all, but I have tended to treat like system and integration tests as a luxury that I use sparingly. But now that they're so fast, they're basically free. So we end up writing a lot more of them. So since then, we've rapidly adopted this pattern in github.com. To go back to our stats that we talked about earlier, we showed how the GitHub application grew about 25% last year, except for our Vue components, which grew by over 15 times. We've learned a lot in the process of this really incredible growth. One of the main things we've learned is how Vue components can help enforce consistency in our application. As you can imagine, one of the goals of our design systems team is to help our developers build consistent UI. And Vue components really have been a key part of this. So for example, last summer, my colleague Christian built a Vue component for all of the counters that we use throughout the application. You can see them here in the repository navigation. And we rendered these counters about 100 different places in the application. So let's have a look at one of his PRs. We can see that for one of the counters he replaced, on the same page, we wrapped the amount in this number with delimiter helper, which in this case adds like a comma. In the other case, we didn't. And this led to really subtle visual inconsistencies on the page, but only in edge cases with very large numbers that you never expect a developer to think about when working on a feature, let alone have that much data in their local environment. So instead, with his change, we simply pass the raw count to our primer counter component, and that component handles formatting the value and then displaying it in a consistent way. Another benefit we've seen from ViewComponents has been in helping developers write performant code. One of the most common performance issues I've seen in Vue code is unintentionally querying the database. So for example, we have these permission checks in our views to determine whether to show certain elements or not. So for example, on a comment, we might see like, okay, if you're able to write to the repository, you actually get an option to edit a comment. Unfortunately, these checks can trigger queries if we haven't batched them properly ahead of time. So to help developers understand how their Vue code might interact with the database, we actually redefined that render inline helper, you've seen it used in our unit tests, to accept a number of allowed queries defaulting to 0. I think that for a lot of us, we kind of have an implicit assumption when we're writing some of our code that it just doesn't generate database queries. This approach actually codifies that in a test harness. What this does is that when we render a component, we'll fail the test if it makes more queries, and actually even if it makes less than expected. So if you say 5 and it does 6 or 4, it actually fails the build. This helper has been super educational for our team. It's really helped us better understand the side effects of our code, and it's prevented the introduction of many n+1 queries. In one recent case on the checks page, you've probably seen this. This is our checks page for our monolith. We actually saved 100 milliseconds per request due to n+1 that this safety mechanism detected. And just recently, we've actually started trying a similar approach for preventing regressions around memory allocations as well. So we'll say that this operation makes 113 allocations. So when you go to refactor that operation, you can then ensure that you're not over allocating. We have some really hot code paths and components that are rendered thousands of times per page, and we want to make sure that our memory usage doesn't unintentionally grow when we don't mean to. Another advantage we've seen with ViewComponents is how they can really help us manage complexity. And one example of this has been in writing mailers. So as y'all probably know, writing HTML emails is really hard. It requires writing HTML like you're working on that original Space Jam website from 1995. And it's fraught with edge cases. So most of our mailers are written with what I would refer to as heavy-handed inline HTML. It's incredibly hard to maintain, let alone change something without breaking it in some random email client. So when a designer came to us and said, "Can we add columns to a mailer?" you can imagine our response was not one of great excitement. But my colleague Mike thought we could build some Vue components to abstract away all of the complexity around all the tables and inline CSS you need to pull off this design. So to do this, he wrote some mailer-specific components for rows and columns, which we then use together. In this case, you can see that we have a mail row component that we passed some basic classes to, which then contains multiple mail column components. Together, this gives developers a reliable way to build column layouts and mailers without having to go back and learn how to write that old school HTML. And I think that this is one of my favorite discoveries working on this project is this ability to create what DHH calls conceptual compression. By simplifying the process for building mailers, we've practically removed the overhead that you need to know to build one correctly. So instead of worrying about whether you've written your inline styles and tested it in all these different email clients out there, you can just piece together a couple of Vue components and be confident that you did something more or less correctly. And if you think about this, this is kind of like what Active Record has done for us with SQL, or what controllers have done for us in terms of responding to requests. We use Vue components to make building UI correctly the default, not the exception. Another way Vue components can help simplify building UI is with a feature we call slots. Slots are a way to pass multiple blocks of content to a single component object. So let's look at an example from our system. This is our box component from our design system. It has a header, a body, it can have multiple rows, and it has a footer. Pretty common pattern. I think you've probably seen this in something like Bootstrap too. And here's the HTML used to generate it. We have this box wrapper, we have this header element. It happens to have really is supposed to have an h3 with this specific class, all inside this div with the box header class. We have a body class. We have rows. If they exist, they need to be inside an unordered list. Each of the list items needs to have a box row class. And we have a footer, which is kind of like the header, and then it just has a specific class. This is a bit of complexity to expect someone to work with. So let's rewrite it as a view component and see how that goes. So we'll start with a component that just renders that example code. So you can see we have a Ruby file. It does nothing. We actually don't even need that initializer. I don't know why I included that here. In our template, we literally just have that HTML we just looked at. And then when we go to render it, we just instantiate it and pass it into the render method. So skipping forward a few steps, you could imagine in one world that we might end up with components for, for the header, the body, each of these rows and the footer. But this really puts a lot of burden on the developer using all these components because, as you can imagine, the order of these matters. Like the header should always be first if there is going to be one. The footer should always be last. And really, this doesn't prevent people from misusing the design system. So this is where slots comes in. If we go back to our component, we can declare slots using this render syntax for the header, body, rows, and footer. You'll notice that we've specifically said that this component renders many rows, implying that we have some sort of plural relationship. So in the template that renders the component, let's skip a couple steps and refactor it to use those slots instead of separate components. So you can see we now are still rendering our box component, but instead of just putting random HTML inside of it, we have these named blocks, one for the header, for the body. We'll pass in, we can actually call the row one multiple times because we said that we're going to try and render many rows. And then we have one footer. So how do we use this? In the component template, we now will then have access to that header value, the captured value of what's passed into that header named block. We can wrap that in the correct h3 tag and the correct div with the correct classes. We can take our body and wrap it in the correct div with the box body class. And then for the rows, because we said we could potentially render many of them, they're exposed as an array, which means that we can do enumerable operations on them. We can, in this case, say if there are any of them, render each of the rows inside a UL tag. So this is really helpful for constructing lists of things. You can imagine tables are also fun to construct this way. And then, for our footer, that's kind of just like our body, where it's just wrapped in a div. We do all this inside of that wrapping box div, and that's our component with slots. So as you can see here, we now have a programmatic codification of our design system, and this really helps developers use it properly. Kind of as an aside, these calls could be in any order, and it wouldn't matter. We would still have all the data and be able to inject them into the template in the right order. Another thing we've really experimented with has been Storybook. So Storybook is an open source tool for helping developers write components in isolation. It's incredibly popular. I think the GitHub repo has like 60,000 stars or something. It's mainly used in the React context, but thanks to the work of someone from the community, I think his name's John Palmer, it now supports view components. And here's an example of us using it in action with our Flash view component. So here you can see it previewing a change to the icon and then a change to the variant of the Flash message. This gives us a development environment for building components outside of any specific Rails application. And we actually happen to do this in our Primer View Components library. So we open sourced this library over the past summer, and it now, I think, my notes say it has 24 components. I actually know that it's now up to 40 after a lot of work we did the past couple months. And we aren't the only people open sourcing our components. The UK government's Department for Education has a library of about a dozen view components for the GovUK design system. So one of the common questions I get about this project from folks outside of GitHub is, how are we rolling it out? It's sometimes asked in a technical context, whether it's writing new components, refactoring old views, etc., or in the organizational context, how do we ensure components are used correctly? How do we make the case for this work with people that aren't engineers? So let's start with the technical. So how do we create view components? The first way is by refactoring existing Vue code into components. So for example, before ViewComponents, we used a presenter-like pattern called ViewModels, which you might have seen, you've probably seen it called presenters, but they're Ruby objects that we instantiate and then pass into our views. So here's an example view model. In this case, it's one we use on the repository index view. Grossly simplified for this case, but it has an instance method of status. It looks at a repository it has access to, and based on whether the repository is locked or not, it displays either disabled or enabled. And the test looks like this. It instantiates the view and asserts against these instance methods on the object. So that's a view model. We'd take this object and we'd pass it into a template, and then that template would access values from it. So here's what it looks like rewritten as a view component. In this, in the component itself, the only difference we've really made here is we've changed the base class to be ViewComponent base instead of our ViewModel base class. And for the test, things don't really change too much either. So you'll see we have this render inline method. We pass an instance of the component and then we call assert text enabled. But there's something fundamentally different about this test, despite the fact that it's quite similar to the view model one. Instead of asserting against the attribute of an object like we did with the view model, we're actually asserting against what's presented to a user. And this is something we could previously only do with system and integration tests. And it's one of the main reasons we refactor view models to be view components. They give us the confidence that our view code is working correctly from the perspective of our customers, not that just some instance method on our view model is returning the correct value. We also write view components from scratch. And when we do so, we consider a lot of the reasons I mentioned earlier. Is there a strong need for consistency in this pattern? Are there performance concerns? Is the view complex with a lot of different states? In that case, we might use a component so we can unit test all the permutations. But the most common case for using view components is in place of a heavily reused partial or a view model. When it comes to the organizational side of things, communication has been really, really important, and it takes many different forms. So one of the main ways we communicate about view components at GitHub is via documentation. For our open source primer view components, we use Yard, which is based on RDoc, and we use it in a really clever way that I just really want to show. So at the top of every component class, we write a comment describing the function of the component. We also, in the comments, provide ERB examples of how to use the component. And then, more traditionally, we would provide annotations for each of the parameters in the typical Yard fashion. What's great is that this allows us to write our documentation alongside our code, which in my experience means it's more likely to stay up to date. But then the fun begins. We actually use all of these Yard annotations to generate our entire documentation site. So what we do, we have a rake file, and we start by running the Yard rake task, which parses the project for those Yard annotations. We then load the generated Yard output into an internal undocumented object in Yard called the registry store. And from there, we load the docs for our component from the registry. In this case, we call registry.get with the class name of our component. At this point, we now have the parsed documentation available in a Ruby object. So let's look at that object. That object has the class description we wrote. And it also has data on each of the methods. So if we look at the one, let's take a look at the one that's marked as the constructor, also known as the initializer. So first we can see the names of the parameters, and we can also see the text of the example that we wrote. Unfortunately, this is still ERB. But what we can do is we can instantiate application controller and pass that ERB in as an inline template, and that will output the rendered output of the component. So from there, we have what we need to build a documentation page. We use that data to build a markdown file. We take the class name as the title. We take that description and put it below it. We take the rendered inline HTML and then the original ERB code. And this is a little oversimplified, but rendered on the doc site looks something like this. And if you go to the primer.style/ViewComponents site, you'll see this working in full. But basically, this gives us a standardized approach that keeps our documentation perfectly consistent. I think my favorite part about this is that the documentation is then consumable both via the component's code comments and via the published website. because depending on who's looking for the documentation, they're going to probably prefer one or the other. The other nice thing is that this now means that all of our examples are actually executed, which means that if there's any syntax errors, we find them before we even commit the change. Another way that we communicate with other developers about View components is via linters. It's something I've gotten really used to, but I've never seen linters used as extensively as they are at GitHub. It's one of the main ways that we handle just the immense scale of our application. So for example, we have a bot that actually automatically reviews pull requests for cases where we would prefer that people use View components we've already written. So for example, here we have this old Octocon helper method that we're slowly trying to replace with our Octocon component. So you can see that it's automatically detected that helper method and left a comment linking to that documentation that we generated from our yard comments. This saves us from having to make these kinds of suggestions manually in code reviews. Another way we use linters is with our custom rubocops. So we have a rubocop that encourages people to use View components instead of view models. It looks at the class syntax tree nodes, and it sees if the class is a view model. And if it is, it adds an offense with a really helpful message, as is very much abbreviated here. As you can imagine at our scale, if we want to do something consistently, really the only answer is tooling and metrics like this that can guide people towards the right solution. It's simply untenable for us to be reviewing every single new change to our code base like this. Another way we communicate about the project is with weekly updates. So for a lot of our projects, we use an issue to track our projects, our progress on the project. Every week, we share a handful of highlights. We share some examples of improvements we've made using the pattern. And in fact, like almost this entire talk today is literally just the highlights from my last year of updates that I've written on this. And this approach provides company leadership with case studies that they can quickly drop into their communications about our work to justify spending, the very real resources that they are in our project. At some point though, there's really no substitute for just putting in the time on this kind of work. So over this past summer, we put together a team of about a half dozen engineers and spent 2 months building new View components and rolling out existing ones. And here's how it went. The results were really dramatic. So this is a graph of how many places we render a component in the github.com codebase. The graph is really stable until August 1st, when you see this slope change quite suddenly. So for the items marked 0801 and 0901, that's where the team actually worked on the rollout, and we quadrupled the number of uses of components in our codebase. But then we stopped working, and the graph kept going up. So how did this happen? A big part of it is that we now had a critical mass of examples of those components that developers were then able to copy and paste as they built new interfaces. But how do we ensure that they're copying and pasting the right thing? We do that with, as you might have guessed, more linters. So for example, if I was to use the non-component implementation of that counter component we looked at earlier, I'd actually get this message in the build. For each component, we set a number of places we allow the non-component implementation to be used. And if someone adds another usage, this linter fails their build and suggests they use the component. As we roll out a new component, we decrease the number of those exceptions, preventing new ones from being introduced. We also use the same code path to generate a report on our progress. So for example, this is actually from the actual results. I ran this the other day. In github.com, for our blank slate component, 100% of the places in the application you see it are rendered with View components. It's 492 places. So one of the other questions I get about this project is, what have I learned by open sourcing it? I should caveat this entire section by saying that this is the only open source project I've really worked on. But by many measures, it's been very successful. We've been lucky to have a lot of engagement on the project. We've had code contributions from over 100 developers, only a dozen of which work for GitHub. In fact, I think a couple folks here in the chat are on this list, if you look very closely. And working with so many people from all around the world has been a huge lesson in empathy. What stuck out to me is that in every issue, pull request, or discussion post that we get on the project, there is something to be learned Even the small stuff. If someone was confused by the documentation and wrote a component incorrectly, it's evidence that we can improve our docs. If an error message doesn't help someone fix the error they ran into and they file an issue about it, we should probably fix the error message and make it easier to understand. It's clear to me that people really want to contribute, but they're not always sure how. And this is why we've really focused on making it easy to contribute to the project. We really want to enable people to make the highest quality contributions as easily as possible. And the library is growing in complexity, and it has some nuance and differing behavior across Rails versions that are tough to take into account when you're working on it. We support the combinations of several versions of Ruby and Rails, and making sure the framework works correctly for all those combinations is really critical. So one way we've reduced the burden of this is through using matrix builds. So by running the test suite over about a dozen combinations of Ruby and Rails, we're able to ensure like every change works across all of these combinations. But perhaps more importantly, it's enabled us to ensure that despite all those nuanced behavior differences between the versions of Rails, we can still check for 100% test coverage. And we do this by combining the coverage data from all of these matrix builds. And what this gives us is a confident foundation that makes it easier to accept contributions from the community. And we do this with build artifacts. So in our actions configuration, we upload the contents of the simple cov directory as an artifact on every test build. And then we define a dependent build that runs after all of the test builds, and it downloads all of those coverage artifacts, and then runs a rake task that combines the coverage results. This task loads all the artifacts into simple cov, which actually has a collator specifically for this purpose of combining the results from multiple builds. We then configure that collator with a 100% test coverage requirement, which means that a build will actually just fail if it contains untested code. With all this infrastructure in place, it's a lot easier to accept PRs with passing tests from the community because we can be sure that they don't break any existing APIs. Another lesson I've learned is, working on this project is just how powerful Rails conventions are. When writing this project, we aimed to align it with Rails as much as possible. And by stating that goal, it's meant that some of these Rails conventions have established baseline expectations outside of Rails and into our project. What's been really cool is that in practice, these conventions have further enabled people to almost instinctively know how to contribute. So for example, Juan Manuel from the community contributed ViewComponent previews, which are largely based on the convention established by ActionMailer previews. I also think it's worth talking about what hasn't been going so well with this project. There really is one problem with this approach that I can't shake that I think is best summed up in maybe my favorite web comic of all time from XKCD about how people complain about existing standards and then they say, oh, let's go create a new one. And then all that's left is more competing standards. In practice, this means, by having view components, we now have two ways of writing views in Rails applications that work very differently. And because of this, I can't imagine Rails having like truly native built-in support for this pattern, at least as they exist today. You have to write them in like a separate app components directory. They don't go in app views. But it makes me wonder if we could extract some of the lessons from this project back into Rails. One example of this is an experimental gem from Andrew Culver and Dom Christie called Nice Partials. And Nice Partials provides a similar API to ViewComponents slots, and it allows you to pass multiple blocks of content into a partial. Maybe this is something we could add to Rails. I think this is what we ultimately need to focus on in the long term for this project, is that from our work on ViewComponent, we've identified a lot of ways that the Rails view layer could be improved. And as the ViewComponent API matures, we'll have an increasingly clear idea of what those improvements might look like. And by doing so, we'll really be able to have we'll have the ability to design the future of building UI in Rails from actual experience and not just from hypothesis. One example of this problem is the unfortunate lack of support for caching in this new framework. Because we really don't do view caching at GitHub, so it makes it really hard for us to build the support for it in the framework that is going to be right. This is one area that we could really use one of y'all's help, or many of y'all's help on the project. But more broadly, this project has really made me think about innovation in Rails and Ruby in general. There's a really famous business book, widely considered maybe to be one of the most influential ones of all time. It's called The Innovator's Dilemma. And the Innovator's Dilemma is the decision between catering to current needs or adopting new innovations and technologies which will answer future needs. And the book really demonstrates how successful, outstanding organizations can do everything they think is right and still lose their market leadership or even fail as new, unexpected competitors rise and take over the market. And I think this is an important lesson we need to consider about the long-term relevance of the ecosystem we work in. The reason this matters so much to me is that GitHub's future is pretty dependent on Rails and Ruby remaining relevant. We have so much built on top of these technologies, and it's very unlikely that we go and rewrite what we have written in them today. So what does that mean for all of us? It means that we need to continue to innovate. We need to experiment with new and potentially disruptive ideas like ViewComponent, because improving Rails and Ruby is the only way we'll survive. We need to take ownership of keeping our ecosystem relevant for the long term by being good citizens, by participating. The technologies we use are open source. They're built by people just like all of you, and we benefit from the work that others have already put in. But we need more voices. We need more extractors. We've all worked on we've often worked on many applications in our careers. We know what the underlying deficiencies of these technologies are. We know what gems we pull into every Rails application. We know all the pain points. And the survival of the companies we work for depends on it, because picking a framework and a technology and a language is forever. Rewrites are really rare, but yet the world will move on regardless, which means that it's up to us to keep our ecosystem relevant. Thank you.
Thank you, Joel. Yes, definitely it's up to us. That was a beautiful message there at the very end. Thank you so much for sharing with us your story and the story of ViewComponents. There was already a question in the chat by Marco asking, what about the styling of the component? Is it in the global page style, or there's a clever way to load it if it's used in a template?
Oh man, I feel like that was one of the. That's a very future looking question. That's literally a problem we're working on right now. One of the things we've been doing is we've been trying to incorporate things that have gone well in the React ecosystem and bring them to the Rails and Ruby ecosystem. And we've started with the really easy ones, like where we're at today. We've done all the easy ones. One of the hard ones is CSS encapsulation, like delivering styles in a way that is congruent with the ViewComponent architecture. And if y'all go to the ViewComponent repository right now, there's actually a pull request open with a proposed architectural decision record, which is like a technical description of how we might solve that problem in the framework. That's actually a problem my team is about to take on, which is, we have a ton of styles at GitHub. We have 500 kilobytes of custom CSS. I actually think it's more than that now. And serving the correct styles in the right place is something that we really struggle with. And I see ViewComponent as a key part in solving that for the long term for us. And maybe I'll come back next year and talk about how that's gone.
That would be great. There's people saying that they love using ViewComponent in production. So I think you're on the right track there.
I think we are too. It's been, it's crazy. I remember when we first wrote this I built this prototype. It was really hacked together, but we put it in prod and it worked really early on when Aaron Patterson, Tenderlove, and I built the original prototype back when he worked at GitHub. And that was it was a really exciting time to just take an idea like this and actually see it work. And it's continued to grow now. It's been about 2 years since, 2.5 years, 2 years since we started the project. And it's been nothing but fun.
Yeah, and it's walking all alone now, so you don't need to hold his hand anymore.
No, exactly.
There another question. Did you consider to go with views as objects before going with components? And if so, why the components one?
maybe I could ask a clarifying question. Is that referring to not having a template at all?
Let me ask that.
I think that was Luca.
Yes,
Monica.
Luca is asking, yes. In the meantime, we can answer
Yeah.
Jaffa's question. Do you have coverage for the components template?
That's actually something I've been looking at right now. So the nice thing about coverage is that, you know, we at least get it for the Ruby object. There is, I didn't go into it today. If you look at a previous talk I gave, I think from last year, called Encapsulating Views, it talks about the compilation process. Rails views are actually compiled into Ruby code. There was some like inferences to that in my presentation today. That compilation step makes them difficult to measure code coverage for. However, there is a library called Covered written by Samuel Williams from the Ruby core team that we're looking at integrating for coverage. I don't know if it works with every templating language. I think it does. But that's actually, it's funny. Everyone's asking questions about like literally what I'm going to work on next month. Like maybe we are about to hire a bunch of people on our team. So if you're asking these questions, have a look at the careers page in a couple of weeks and send me your resume so you can come solve it instead of having me do it.
I guess people are really eager to use it. So to recap, the question by Luca was, did you consider to go with views as objects before going with components? And if so, why the components one? And
yes.
his answer is template and view.
Yeah, so the reason we went with using a template, actually, the correct answer is we did go with just objects to start. So the original implementation did not have a separate template. It had I think it literally had like a template class method that had a here doc inside of it that would be like here doc, ERB, or whatever. That did not work out for a couple of reasons. Some of them are silly and some of them are very technical. The silly ones are that the github.com syntax highlighting engine does not highlight here docs properly. So when you would like open a pull request and you'd have a component with a template in there, it was really hard to read. It also got kind of messy because like in a template, your nesting starts at the left side of the farthest left column. But if you had it in a method, it might be 3 or 4 indentations deep.
Yeah.
And then if you had nesting in your template, it would get really nested in your component. So there was some cosmetic concerns. I also gave an original talk on this in I think it was in Taiwan, and one of the Ruby core team people basically told me that these inline templates were going to be tricky to deal with the coming Ruby 3 typing work that was discussed today. That it might not be a super fun experience to mix syntaxes in a file. And just generally across the development ecosystem, I have found in practice that having one type of syntax per file is a more pleasant experience, and that's something we've generally found at GitHub. I think a couple people have written extensions that allow you to write the template in the component. So maybe we should link to those in the repository. There's ways of doing it. We aren't really a huge fan of it at GitHub, but everyone has their way, and it's open source, so you can do with it what you want. Yeah.
Yeah, that makes sense. Thank you. We have still 8 minutes left for Q&A. Then I'm going to ask you your question.
Okay.
Are there other ways you think the Rails view layer could be improved? Because I'm curious.
I think that the thing I'm trying to wrap my head around right now that is really difficult is what we think a modern version of the asset pipeline should look like. I kind of touched on this with my comment about CSS encapsulation, but there seems to be like a certain level of skepticism about the Webpacker, Webpack driven architecture that is currently in Rails. Just a lot of these things are in flux. And I think that what I'm trying to think about is how can we provide that traditional like convention over configuration, like really easy works out of the box approach that is still modern and adapts some of the things that we've learned over the past 13 years since Rails, or 14 years. Yeah. I love your cat.
Yeah, it's feed time for her. So that's why this is how my meetings look like constantly. Like, can you imagine this? Anyways. There she is. Thank you. I'm sorry if it was too distracting.
It's all good. It's all good. This is the Zoom life here, right? Just
I know, right? Yeah. It makes me human, apparently. So yeah, I guess there she is doing her things. Thank you so much for having been with us for today. It was great to meet you. I really do hope we meet in person next year. So keep working on that stuff. I need that. Okay. And have a lovely rest of the day.
you too. Take care. Thanks for having me.
Thank you. Bye.
Bye.